Let's move on the section called movement. So this section is all about the directions and how the forces of our world physics affect the animation and therefore the motion and the direction of these elements. So this section is divided in two. The first one is movement within screen bounds, and then movement in and out of screen bounds, as we just described with the menus. So the movement within screen bounds. So these are elements that animate in the screen. It could be a button, it could be a picture that when you tap opens. So these are elements that stay within the screen. So they show that when you move upward, diagonally, it shouldn't be just a movement, a straight movement from the bottom left corner to the top right corner. It should have an arc. Okay, now this arc is justified by the fact that there is gravity in our world. Right, so it will pull it slightly down.
Lifting.
Exactly. And even the animation itself starts slow.
So
It's
imply
like
that it's gaining force.
Velocity.
Velocity,
Exactly.
It's interesting too, because when you watch both of these, you can see that one feels more intuitive and natural to us to watch, and the other one it feels wrong. Something about the don't obviously feels wrong.
Yes, exactly.
That movement is not something that we
expect.
Recognize.
It's unnatural.
Yeah.
It's beautiful. And the same is for when animation moves downward. Same thing. When something moves down, we want the arc to face down, and we want something to slow down, like if it's decelerating because of some friction. When not to arc. Now, this is an example where they explain not to arc something, and it's usually when there are vertical or single axis movements. So, top to bottom, or vice versa, or left to right. In that case, they say don't use an arc because it doesn't really make sense. Okay, this is objects entering and exiting the screens. Also move along single axis. Same thing. Okay, the second section is movement in and out of screen bounds. So this is about how things should accelerate or decelerate when coming in and out of the screen. So they show, apply the deceleration curve to items entering the screen, so that they decelerate as they enter the screen. Again, there is some friction. And they accelerate as they leave the screen. But only when they permanently leave the screen. Okay. If instead they were like just going outside and hiding for a moment, and you need to take them back again, then you would decelerate them instead of accelerating, because it suggests the fact that it's still there. Temporary leaving screen, that's the example. So you can see this is like a side menu. So it always feels there. And in this example instead is of a card that gets deleted by the user. You can see that it clearly suggests the fact that the card is leaving the screen forever. Relative movement. So this is the movement relative to another object. So entering or exiting objects that move other on-screen elements do so along a smooth easing curve. So they remain minimally disruptive to avoid eye-catching dramatic movements.